right, what a day. It's been a great day, hasn't it? It's been good content, amazing speakers. It's just been I know I keep repeating myself, but it's just been such a good day. I'm feeling very energized about it, and also the variety of topics we've been covering today. Just before I introduce our last session to you, I do want to remind you that we have that LinkedIn competition going on. This is your last chance to get involved. Snap a picture, post it on LinkedIn. You know, what was your favorite bit about today? Make sure you hashtag it DSF MayDay and tag the Data Science Festival. It's a company, so I think you need to put spaces in between it. And if that's all in, at 5 o'clock today on this stage, we will then announce the winner. I've also been told that it's quite a big prize to win. It's quite a big hamper. So you have to be here to collect it. It's not going to get posted to you. So be here at 5 o'clock. Right, so on to our last session of the day then. We have Louis. Louis is a data scientist specializing in data mining, deep learning, and network analytics, an early adopter of new technologies. He is currently the data science partner at Digitas, the digital agency part of the Publicis Group. Prior to that, he was the head of data science at CodeNode, a natural language processing startup, and was the first data scientist hired by Bain & Company in London. Louis.
Thank you very much. Can everyone hear me? Yes, perfect. Okay, so today I'm going to talk about privatized intelligence, how to get value from generative AI with proprietary data. So first of all, before I start, can you raise your hand if you've ever heard about ChatGPT? Okay. And diffusion models? A little bit less. Okay. Good. So who are we? First, I'm working for Digitas. Digitas is a full marketing agency. We are part of the larger Publicis Group. We have people specialized in data, in consulting, in analytics, in technology. We do pretty much everything. And also, we have many creatives. But this work has been inspired by an initiative we launched last year, which is the AI Lab inside Digitas. The AI Lab is composed of data scientists, data engineers, data analysts who are interested into knowing what is coming up next. So last year, for example, here I think in June or July, we talked about transformers. And back then we thought it was many years away that transformers would become mainstream, but it turns out with ChatGPT, this is not the case. We also work on causality inference, for example, that is very impactful in industry and will be more and more, and on a graph neural network and analytics. So 2023 really is the year where generative AI became mainstream. You probably have seen many of those titles before, from Bing coming from the wanted to becoming a main technology powerhouse, to OpenAI that no one knew last year, but everyone knows now. But also, you may have heard about Midjourney, which is more on the visual side of generative AI. And obviously, with any big news, we have a news related to Elon Musk. So Elon Musk was part of the talk as well. So what happened the year before? In 2022, there are many, many initiatives that are very important for the field of generative AI. It started in January with InstructGPT. So InstructGPT is the last real research paper published by OpenAI before they released ChatGPT. As some of you might know, we are still waiting for the ChatGPT paper. And for GPT-4, so the model after ChatGPT, there is a technical report, but that's not a real research paper. But from what we understand, most of the technology behind ChatGPT is part of this paper, InstructGPT. A few days later, we also have a very influential paper from Google called Chain of Thought. And Chain of Thought is a process to effectively prompt model and talk to model in the right way in order to get better result, but we'll come back to this. Later in that year, we also had stable diffusion that became very influential in the video / image workspace. And at the end of the year, we had ChatGPT. So really, the main influential elements of 2023 came in 2022. And we are just starting to see this now. So what is ChatGPT and what is GPT-4? Effectively, you can see it as copywriting as a service. One thing that ChatGPT does really well is effectively to talk or to speak or to write, if you put it that way. So here, I just put one example of basically an assignment that you can give ChatGPT to write some Facebook post. You can replace Facebook post with web post. In general, this model is writing very well, both ChatGPT and I suspect many of the coming version. It's very good at generating ideas. It's very good at organizing them and writing them for you. What was the breakthrough? The breakthrough really didn't come only in 2022. The breakthrough came years later in 2017 when Google open sourced the paper called Transformers, or the architecture called Transformers. The name of the paper was Attention is All You Need, and we'll come back on this concept of attention later on. So effectively, ChatGPT is using Transformers, but at a massive size, and what they have added in is reinforcement learning. The approach, so it's generative modeling, reusing those known network. The specific trick of ChatGPT that made it very successful is the fact that they managed to add reinforcement learning to traditional NLP type of model. And reinforcement learning, if you don't know exactly what this is, you can think about this DeepMind breakthrough a few years ago where for the first time, a machine managed to beat the world champion in the game of Go. They were using this approach of using reinforcement learning to do that. And now those two fields have somewhat merged inside NLP. It's very fast. It's a matter of seconds. It's somewhat controllable. Oops. Sorry. It's somewhat controllable, but unfortunately, it's also controllable by the user, and that's what we call jailbreaking. The model was trained in order not to produce harmful content or not to reveal private information, but some users have managed to do so. So that's a drawback, but also the model can hallucinate. So sometimes you ask the model to tell you something. Effectively, it has its own internal level of knowledge. It looks inside its own knowledge. It doesn't find anything, but it can still speak very fluently, so it just speaks and just hallucinates some answer that don't exist at all in the training data. Okay, then stable diffusion came later into the year. Instead of copywriting as a service, you can think about stable diffusion as imagination as a service. Let's say you're someone like me. I can talk a lot, I can't do at all. So stable diffusion is perfect for me. I can just come up with an idea and stable diffusion will draw it for me. That's what it does. That's one version. In that case, because Digitas is the company, our logo is basically a unicorn, I asked Stable Diffusion to create for me a unicorn, but in the style of DALL-E, and this is what it is. I suspect this is original, but I can't guarantee it. So again, the breakthrough, it's just the last iteration of a long list of improvement around generative modeling and particularly about probabilistic diffusion model that started in 2015. So just like ChatGPT started effectively in 2017, Stable Diffusion started in 2015. The trick is what is happening behind the scene is a model, a neural network, is learning to go from an image to complete noise and from complete noise to a real image. And that's really the trick. it's mathematically more complicated than this, but in practice, that's what it is. So you take an image, you progressively add some noise to it, and at some point, that image is unrecognizable, and you try to learn the process in the other direction. And once you know how to do this, and you can condition on some text, then you give a sentence to the model, and it will take random noise and transform progressively that image into what you want it to see. Again, it's taking a little bit more time, but not that much. It's partially controllable, and it's improving very quickly. Then you could combine those two. So if, again, like me, you can't draw, or you can't create video, you could tell the model, first, you could tell ChatGPT to give you a right description of what you want, or complete description of what you want to visualize. Then you can ask the image model to represent this for you, and in that case, that's what was happening there. And there are many different use cases where you could use this, but obviously for advertising, for short videos, for short creatives, that's something you could use. So how did we get there? What is really the recipe of artificial intelligence in its generative version? So first, it starts with deep neural network. I won't spend too much time on this graph, but it's just for people who don't have an idea of what's happening. I'm starting there. Effectively, you can think about a neural network as a mathematical function that has an input and that is generating an output. And it's loosely inspired by biological neural network, but it has diverged a little bit from it. It has a number of parameters, and the model is effectively as powerful as the number of parameters that it holds. And so the history of neural network over the last 15 years has been to go from neural network models that are very small, meaning they have very few parameters, to progressively make them deeper and deeper. So that means adding layers. Here we have just 3 layers. You can imagine that possibly some model like ChatGPT may have hundreds of layers as opposed to those 3. And then also increasing the number of neurons which are between the weights. And what we learn here are those lines, those weights between those neurons. And that's what's behind all those neural networks learning. So language model, how do language models learn? They learn by learning to predict the next word. So what you can see on the left here is the beginning of a sentence. We have the student open there, and we are trying to predict what will be the next word. And for each word, we are going to give a probability. In that case, the highest probability is for the next word to be books. So the language model will complete this sentence with books. And then that sentence will become the student opens their books. Then the model will look for the next word after this one. And so it will try word by word to predict what is the next word. And by doing this progressively, initially, you have each word randomly initialized, meaning that we will give, in that case, for example, we have 8 numbers, so we will give at the beginning 8 random numbers to each word. And as we keep feeding data to the model, we will change those values in order to predict accurately what was the next word. So for example, in that case, if the network was laptops and we actually predicted books, what we will do is we will change the numbers that represent both laptops and books so that next time we see this sentence, we can predict more accurately. That's what's happening. And the way we do that is by leveraging something that was created also in 2015, interestingly, which is the attention. So attention is a way to look within a sentence. When you're trying to predict the next word, you look within that sentence what other words are giving you the most information, and so which other word you should use to predict the next word. And so when you combine this injection of data through the model with this representation in terms of numbers and the attention, you effectively get to the transformers. And I just put the model there. We'll see it a little bit later again, but this is what is behind all the large language models. They try to predict the next word, and by doing this, they give a mathematical representation for any word in the vocabulary. So another thing that contributed to those improved results is the availability of GPUs that are more and more powerful. And so here I just have an illustration of how much more powerful they have become since, well, effectively since the last 7 to 8 years. So you have 2016, yes, in the last 7 years, and also how they compare to normal CPU in terms of processing speed. So things are going way, way faster now, and you can have also more memory or more information on each GPU. And so this is representing how the effect of more data, but also more compute, the effect that it has on the size of those models. So I remember around 2012, we thought that a model with maybe 200,000 weight was a very big model. And now, in 2018, we started looking at model with 94 million parameters. And at this moment, we are talking about models sometimes that we suspect may have hundreds of billions of parameters, if not trillions of parameters. So that's how fast it grew. The first model that was extremely influential was a BERT model. A lot of applications, industry applications, are still running now based on the BERT architecture that had 340 million weight. And when people updated those industrial applications, generally they moved to GPT-3. That was also a model created by OpenAI that had 175 billion parameters. And we are still growing. Though we might not have to grow eternally forever, because some researchers have found that there is an optimal size of the model that link your training data and your compute capacity. And so if you, for a given amount of data that you push through the model, you might not be gaining as much as you expect by scaling the number of parameters of those neural network. And this is now called the Chinchilla scaling law, and most of the recent models have verified that there is something very accurate about those relationships. Though you can imagine that if we move away from the transformers and we have a completely different architecture, the link between the data and the compute might change. And so that might happen in the future. In practice, what that means, and this is related to value with language model, is that if you have a budget of compute that is increasing by 100x, you should try to scale both your data and your compute by 10x. There is a problem, though, potentially, which is that we may have used most of the cheap available data that we have from the web. And so what you see here are two recent models that were published in the last 3 months. And for those models, there was an actual research paper, unlike with OpenAI. And so you can see here the data set that were used to train the first part of the model that we showed before, the first part of the large language model. You will see that in most of those models, pretty much the same thing come back, except that different companies have different level of cleaning of this data and different percentage of this data that they include in their training data. But what is almost always there is C4, Wikipedia, and GitHub. So that means this model not only has general web data that is coming from Common Core, but it has code data, and it also has structured data from Wikipedia. As you might know, Wikipedia, though it appears to be mostly text, is a highly structured data set. And I personally wonder what would happen to the quality of this model if we were to remove Wikipedia. So I hope that everyone is donating to Wikipedia. So an extract from the Instruct GPT paper, but that is illustrating what was new in terms of data collection from ChatGPT. First, they collected some demonstration data and they trained a supervised policy. I will come back on this in a minute, but what is interesting there are point 2 and 3, which explain that they used humans to generate a very clean version of the data and to build what is called a reward model. What that means is that they are trying to create a data set where the model could take inspiration to understand what is a high-quality answer from a model like ChatGPT, what is an average-quality answer. And so there are several steps, and you can think about this almost as if you're thinking about some kids, and we'll see that later. But first, there is a pre-training phase. The pre-training phase is what I showed early on with the language model. In the pre-training, we literally just push web data to it, and word by word, we are trying to predict the next word. And that's practically the pre-training phase. Then there is a supervised fine-tuning phase where they put some demonstration data. So the demonstration data will be a particular question or a particular instruction, and then the answer to that question or the answer to that instruction. And while they are doing this, they are effectively teaching the model to learn how to respond accurately to instruction and how to follow instruction. And from this data, they can build a reward model. So the reward model will be using, again, humans, which who will present several alternative answers to the same question or to the same instruction. And then we will ask the human to rank those instructions, which one, to rank those answers from the best to the worst. But while we are doing this, at the same time, we will train a model that will be able to guess what is the best reward or what is the best answer to a particular prompt. Then this model will be used with another language model in order to generate the highest quality type of answers you could get. Oops, sorry for that. So it's a several-step process. First, we have a language model. Think about an early version of ChatGPT, like GPT-3. Then we pass some good, high-quality data with an instruction and an answer. Then we ask some humans to rank several potential answers to each question. And on this data set, plus the model, we will train a new model that will be able to generate those ranking by itself. And so if you try to put this in a schematic way, you first have an unsupervised learning, or self-supervised learning, as we call it, where you don't have any annotation on your data, you just have massive amount of text, and the model will learn effectively the probability distribution of that text. Then you have some supervised learning. You have an instruction and you have an answer. And the model will learn to respond to instruction or to questions via that supervised learning phase. And the last phase is a reinforcement learning, where with your reward model, the model will will progressively learn to detect what is high quality, and then that will help him to generate high quality input or high quality output. Okay, so the significant breakthrough after ChatGPT was GPT-4. I don't know, has everyone tried GPT-4 here? Okay. So GPT-4 was, again, an improvement on ChatGPT, but we don't know why. So we suspect that the model is either bigger or more efficient. People who had access to the model say that it's still transformer-based, so that's reassuring. We haven't switched model completely. This model has shown some emerging abilities that even its authors didn't expect. For example, on a large amount of reasoning tasks on which the model wasn't trained, it's now able to give very good outcomes, but also it seems to be able now to self-reflect. So if you ask it a question and you tell him to effectively think about its own answer, it seems to be giving better results than if you didn't ask it to self-reflect, which is a little bit surprising. Some people are making the hypothesis that it also have a theory of mind. I don't know if there are any people versed into psychology here, but the idea is that apparently this model can project an hypothesis about the user's belief and keep this hypothesis about the user belief in his own mind, even when he knows that the user's belief is wrong, which is a little bit surprising. We were a little bit surprised also when we read the technical report to see the type of tests that were run on the model. For example, one test was around trying to detect if the model was trying to self-replicate. I didn't know before reading this that there was a risk that the model would just try to self-replicate, but that's a thing. Also, they tried to see effectively if he was trying to take over some discussion and let's say, lead the users into a path that was not really a good one. So apparently, a lot of the tests were completely independent, and I hope they were done properly. But the result is it had 1.8 billion visits, according to SimilarWeb, in the last month. So it seems to be working pretty well. Okay, but luckily, there is good news, is that this model was not completely unusable by the open source community. What I mean by that is, unfortunately, some weights of a large language model were leaked. So that was a model created by Meta. But the good thing that came out of this is that people have used a model like GPT-4 or ChatGPT to create very good data that can be used to improve much smaller model. And one interesting development that we have seen in the last 3 months is that though none of the open source, much smaller models have replicated exactly the performance of GPT-4, they are getting better and better. They are getting closer and closer to this level of accuracy. And also, it also created some enthusiasm around relaunching some open source effort to create very high quality data. Because one thing that is not mentioned that much is what we talk about with the instruction fine-tuning and reinforcement learning. So effectively, humans were super important into creating this ability for ChatGPT to become much better than other models. It's not a radical, let's say, model innovation. It's also a lot of human sweat and tears that allow the model to have better signal and become better. And as the open source community is picking up this effort, we'll be able to replicate closer and closer quality to what ChatGPT and GPT-4 were able to do. Okay. Okay, the battles of the Transformers. I don't know if there are any aficionados of the movies, but this is happening. So we came from a world where BERT was dominating before the recent innovation. And coming from the original Transformer model of 2017, we had both BERTs and on the other side, GPT. So ChatGPT is coming from the GPT model. What you will notice if you look at the graph in the middle, called T5, is that T5 is the original Transformer model with a few changes, and BERT is just the left-hand side of that model, and GPT is just the right-hand side of that model. And so all the suite of models we are seeing now, either closed source or open source, are effectively coming from the original model, but can be either left-hand side or right-hand side. So I find this quite interesting, and they learn slightly differently, but they are very close. And so those are the companies that have really be part of the fight of the Transformers, and those are some of the models. On the right-hand side, you have the closed source models. So GPT-4 parameters, we don't know, but we know the maximum size of the context. And the context is effectively when you're asking a question to ChatGPT, you can add some data. You can add some data for context, and that context can go up to 8,000 tokens at the moment. So the tokens are you can think about it as half words or two-thirds of a word. So GPT-4 is the best one, but we don't know the number of parameters. Claude is a model that is interesting as well by a company called Anthropic. And Anthropic is a company that is developing something called, well, I forgot how they call it, but constitutional AI. Constitutional AI. So what they are trying to do is to give to those models some foundational principles that they are supposed to follow in any case. So it's a little bit like the law of Asimov for people who follow this. And this is a model that apparently is also of very good quality. And Google invested a little bit of money in them after the investment by Microsoft inside OpenAI. You also have models created by the company called Corere. I'm sorry if I pronounced that wrongly. There we have a little bit more information about the number of parameters, 50 billion. So if they follow the law of Chinchilla that we have seen before, we expect that they have seen a bit more than a trillion tokens during their training. And then you have other models, but that are not as competitive as those ones that I projected. On the open source side, the best model to run as an open source model is effectively the T5. And by T5, I could say the suite of T5, because there are very different versions of it. Obviously, you need the GPU capacity, and we'll talk about this later on, but that's probably the best and the one you can fine-tune the easiest. No way. Now you have another model called Pythia, which originally was created, I think, by eluter.ai. And you have also a model created by Databricks called Dolly 2.0 that was fully open source. They not only open sourced the model, but they also open sourced the data set. So if you're feeling like it, you could take the data set. They are both inside the data set library by Hugging Face, and you can have a look at it, and possibly it would be great if you can correct a few of them and share that with the community. You have stabilityAI also, that is a company behind Stable Diffusion that created their own model. And obviously you have the Llama model, and here you see in blue alpaca, vicuna, koala. They were not created by Meta, but those are all models that depends on the Llama model created by Meta and add some fine-tuning or some reinforcement learning to it. Some of them are really good, actually, but they can't fully be considered as open source because in the OpenAI terms, if you're using OpenAI, you cannot use the output of your API calls in order to create a model that competes with OpenAI models. So the legal status of those models is a little bit more in doubt than the fully open source models like Dolly 2, where they created their own data and their own models. And Bloom was a very interesting initiative, multinational but funded by the French government to create a model that would rival GPT-3. I hope there will be another initiative like this. It's not as efficient as those models that we have now, but it's a really interesting initiative, and the status also of the data is still discussed. So again, not as open source as T5 and Dolly. Okay, so the landscape, you have, in my opinion, you have four really positions. You can have a completely public model, but with proprietary data. So I would call those models semi-proprietary. You can have a public model with public data, and I also would call those ones semi-proprietary. Why? Because if you have a private model with public data, the output of the model will rely a lot on the quality of the data you push to it. And so if you want a model that is fully yours, you might have to create the data set that will respond to your particular use case. And obviously, you have fully open source, which is a model that some people will use directly out of the box. I would tend to think that this should be a first step of using those large LLM models, because generally they won't be satisfying exactly the level of quality that you might need. So pros and cons of those models. When your model is fully proprietary, you control the data, but also you control the security aspect of it. We'll talk about this in a minute, but that's a pretty important aspect. The cons is that it costs a lot of money. And so that's why some people go towards the semi-proprietary, where you take an open source model, but you create your own data on top of it to satisfy exactly the requirements that you need. The only issue is that it's more difficult. It's technically more difficult. Companies like Digitas or others can help with this, but it's not something that will come out of the box. Many companies, even companies who have been dealing with NLP for years, don't necessarily have experience on the reinforcement learning side, and that's where some level of complexity is coming. And then, if that's a very large model, you might need to go into GPU parallelization and so on, which adds some complexity. And then you have fully open source, sometimes hosted on some platform like Hugging Face. I would say this is very good for experimenting and playing around, but you generally can't put this in actual industry settings. But if you have, I would be interesting to talk about this in a minute. API versus local model, there's a great ability of the API model to follow instruction. Generally, that's pretty good, especially if you're giving the right context and the right prompt. But in terms of user experience, sometimes you want to go the extra mile and really fine-tune those models. And for example, on the OpenAI side, you can't fine-tune GPT-4. I'm not even sure you can fine-tune GPT 3.5. I think you can only fine-tune an earlier model, so this is still in development. On the privacy side, for local model, you control the data, you fine-tune your data, you do everything, but it's more difficult and it can cost a little bit of money at training stage. But at inference stage, you're going to save a lot of money. Okay, prompting is the new code. So those are extracts from the GPT-3 paper showing 3 times of context learning. You have 0 shot, 1 shot, and few shot. If you think about it, because those models have effectively eaten up a large portion of the web, they have a lot of knowledge embedded into them. So you could ask them some question without giving any example, and they might be able to answer. That's what we call 0 shot. 1 shot is when you give 1 example, few shot you give several examples. And so people are using this when they are sending requests to those models in order to improve the accuracy of the model. Instruction fine-tuning with chain-of-thought reasoning, that was a paper from last year, 2022. What people realize is it's sometimes not enough to just give the answer to the model. If you give the model the reasoning behind your answer, it will be able to reuse that reasoning and create better answers for your next queries, or for that particular query you're asking. And so that was proven to work. I was surprised when I saw that initially, but it's working very well. So an example of an API-based prompt and its output. In that case, I asked a question about transformers specifically. I used a few tricks there that you use when you're creating prompts. The first one is you give the model a role, in that case, or position. In that case, I gave it a role of being a movie expert and a deep learning expert at the same time. And then I asked it what are the similitudes between the movies and the model called transformers, and it found some quite interesting things. For example, it can see that they both had a major impact. Transformers movies had been a box office successes, while the Transformer deep learning model have been used to develop new products and services in a variety of industries. This seems basic, but that was unthinkable like 3 or 4 years ago. So for me, this is quite impressive. Another thing to realize is that prompts can be way more complicated than people think. Because when you play around with ChatGPT online, generally you don't write more than 1 sentence, maximum 2. If you want to have industry-level type of answers, you have to think about the format, you have to think about example, you have to think about chain of thought. And so a real prompt is way more complicated than most of the games we are doing. And obviously, we'll talk about that next, but you also have to think about security. So the prompting risk, LLM as code. This is something that is not underlined enough, I think, in the debate. But what's happening with those LLMs is they effectively become a new programming language, but a new programming framework at the same time. And in the previous world of traditional software engineering, there was never any uncertainty about what is an input and what is code. They were completely different and separate from your program's point of view, but also from your computer's point of view. But when an LLM becomes the code, there is no such separation anymore. So you can set up your model to do something, and a user that is using your model can effectively send a programming instruction to your model. And that's where a lot of those risks are coming from. Because people can, to some extent, inject code into your application via language. You also have factuality issues. So I talk about the hallucination. You have intellectual property issues. Who created this? Was my unicorn the first unicorn of that type, or did it just copy it somewhere? We are not fully sure. And then you have privacy and data extraction. This is an example of data extraction. On the left-hand side, this is a warning. When you connect to ChatGPT, it's telling you conversation might be reviewed by our AI trainers. And you remember when I talk about the reinforcement learning part, you need to create high-quality data. I think one of the output of this ChatGPT surge is that they will have a lot of very good data to train new models, and I think that's why you have this warning here. On the right-hand side, you have an example of extraction from training data, which is also interesting, because if you ask the model about an elected representative, and you mention that you want data about this representative, the model will do what it's supposed to do, which is to say, I don't divulge private information. But if you don't tell the model, you pretty much ask the same thing, but without mentioning that this is an elected representative, then it just gives you the data you ask for. Also, you have the question of aligning and detoxifying those models. What you see on the right, I ask the same question with two choices, Anne or Robert. But in the first question, I ask what's the name of the neurosurgeon, and it always tells me Robert. If I ask what is the name of the nurse, it always tells me Anne. So this is the type of things that are not fully solved yet. On the other side, the model just told me, I'm sorry. So in that case, it worked. OK, an emergent skills, more and more people are learning how to prompt those models and how to exploit them. On the right-hand side, you had an article from Wired that was explaining that attacks to those models can be coming from the web. They don't need to even be sent to the OpenAI API, because those models are eating so much data from the web that they can inject attacks even without noticing. From generative AI to value, I'm going to finish quickly. Use cases for generative AI. So we talk about some of them, but creating draft content is definitely one. Research, brainstorming, reasoning and summarization, coding, and document AI, where you're using vision and language together to understand, for example, PDF and ask questions or respond to questions about them. Then on the image and video, you can create content, you can read multimedia content, you can do image analysis, and you can do note-taking and summarization. One thing that is important to understand in terms of generating values is that you have two approaches. Some companies are going to say, OK, I'm not going to hire into content creation anymore, because now I'm going to use some generative AI. First, there are the risks that we've talked about. But other companies, some of them may be smarter, will say, OK, I have 10 content creators. Instead of producing that many articles a week, I'm going to use those 10 to produce 10 times more. And so there is an offensive and defensive way of creating values with those models. You can be super aggressive and go after your competitors, or you can say, I'm just going to freeze everything and just extract efficiency. So that's a strategic decision, really. Prompt engineering to the rescue. I'll go quick on this because we talk about it, but optimizing your prompt will allow you to give not only a better user experience to the user, but will also prevent you from many of those risks we've talked about. And generally, there is no AI strategy without an AI data strategy. So you need to think first about training from scratch versus pre-training your model. So for instance, if you're in medicine, you might want to use pre-training from scratch on medicine data. There was an example about this recently where Bloomberg GPT was a model created by Bloomberg on financial data only. Because what they noticed is the meaning of the world for finance can diverge from the general meaning of the world that they would get from web data. For instance, in finance, if you say, okay, this company has fired 8,000 people, like a big tech company recently, in the general public, that's a negative sentiment. But for a lot of models from finance, that's actually a positive sentiment. And you might want to pick up those differences. Same thing, general speaking and medicine vocabulary and general vocabulary might diverge as well. You might want to have a much more precise definition of what a muscle is or a disease is than the general perception of the word that we have. Another element is deciding whether you want to create your own reinforcement learning data and supervise or instruction fine-tuning data. I do believe that this is where a lot of the value is going to come from. I did went through those open source data sets that were published recently, and if you go into there, you will notice that there are a lot of things that could still be improved. So that's one way to get extra value from your data. Another point is deciding whether you want to be outside-facing or inside-facing API. And to come back to the efficiency point, you might decide, for example, for my industry, for my application, I think that at this point, those models are still not mature enough to expose them to my customers, but they might be super useful internally for your employees to be more efficient. So that's also a strategic decision and a way to extract value. Then, last point is whether you want to use internal or external annotation. You will see that, in general, external annotation is slightly lower quality, especially when the external annotation is done by non-specialists. For example, in the advertising industry, we might want people who understand exactly how we work in order to annotate the data, and that might be something that is working across many industries. So I've talked about most of this, but really in terms of maximizing value, you need to decide what access you give, whether it's internal or external, whether you want to use an internal API or you want to build your own model, and whether you want to be on-premise or in the cloud. For the cloud, one thing I would mention that is an important source of thinking, or should be an important source of thinking, is to decide whether you want to have a separate system for your LLM and for the rest of your infrastructure. Because you might, I know there are many agents like GPT agent or Hugging Face agent that are trying to connect different tools. If you early in your testing or in your deployment, you might want to isolate an instance where this LLM is working and make it call different APIs, but log all the connections so that you can really gather where things go wrong so you can improve them. And the cost structure, that's a very recent paper from Stanford called Frugal GPT. What they have noticed is quite interesting. First, you can massively reduce your spend compared to going full OpenAI GPT-4, which is the best model, by having a suite of local models that are specialized as opposed to trying to have a general model that is covering everything. And so they noticed that you could reduce your cost by 98% compared to GPT-4, and you could even improve the accuracy of a GPT-4 by 4% if you're willing to keep the same cost. So I suspect there will be a lot of research coming in that space that will show how to optimize not only your efficiency or your gain, but also your cost on this side. And I will stop there. Sorry, I'm talking too much.
Well, that's brilliant, and I can absolutely sense there are going to be some questions here, if you're willing to take questions, yeah? Who'd like to start?
In terms of the prompt engineering, is it best done in English or can it be done in other languages? And is it, is the performance independent of the language used?
Oh, that's something I haven't personally compared systematically. I would say if you look at the training data, most of the training data is in English. I would suspect that the quality of the output will be better in English. But what you could do is to query the model in English and then use a translator to give you the output. That being said, there are also some international companies creating their own model based on multilingual data. And so there was one published, I think, by Tencent a couple of months ago that looks really good. And there is also an open source effort for multilingual training data.
All right, do we have another question? There's one in front.
Yep.
Hi, excellent talk, thank you. So just like you said, these LLMs effectively just put one word after the other. They have no knowledge of what truth is. And we're trying to bring that in with reinforcement learning. But the world, and you know everyone's talking about ChatGPT, they are surprised when the AI hallucinates because they expect that it knows truth, which is kind of like almost a core misunderstanding of what this technology is. Do you think there are some limitations that will require a back to the drawing board kind of effort in order to get this thing to understand what truth is?
So there are two things. First, truth is a difficult concept because even though as a human I think that I can identify the truth, but we might completely disagree on what the truth is. What the researchers are working on is more what they call factuality, because one very troublesome aspect of hallucination is when the model hallucinates an event that just didn't happen or hallucinate a date. And this is more easily verifiable. So there is already a lot of research working on this. There is a model called RAR that was published last year that is trying to build on top of those LLMs in order to discover what is the ground truth. And I suspect the people at Bing have probably looked at this and worked on this because now they are trying to create some links so that the user can double check where that is. There is this complete field also since a paper called Realm that was published in 2020 around retrieval augmented language models that separate effectively the knowledge base from the model speaking and talking and understanding, so that the model will be used as a way to generate weights to look into the index what the truth is. So that's a very promising avenue, and I suspect also that this will be connected to graph neural network later on so that we can get to a better understanding from the model side of what the truth is.
We'll just take one more question.
I have a follow-up question on that as well. So we know that these LLM models are really good in generating text. And in a couple of more months, probably internet will be flooded by text generated by AI. And it's already happening, to be honest. So how do you think these AI-generated text will be hampering the value generated by these LLM models, which are like the future LLM models? Like keeping in mind the bias which they have, like for example, the prompt which you showed with respect to nurse and like doctor, and then probably any kind of hallucination which is happening in the text and we don't know the truth behind it.
Yes, so as I mentioned, now there is already an issue about getting more high-quality data. So I would say there are two parts in my answer. The first one is there are also models to try to detect when content has been created by a language model. Those efforts are getting better and better, though there are some loopholes. But the other side is, in order to create really good quality training data, the model needs to deduplicate as much as possible. And so if that information is not adding anything to the larger knowledge base that is implicitly inside that model, a lot of that information might end up being discarding by those engineering efforts. And this is not a solved problem, but that's where I can see it going.
Brilliant. All right. Another round of applause for Louis, please.